All right, welcome back to AP Calculus. Today's date is it's Friday actually because I'm recording this in advance, but it's Friday, November 1st. So 11/1, lots of ones there. I hope you guys had a nice Halloween. And again, the deal was you guys have to have all of the homework from 4-7 and 4-8 due on Monday. So we're doing spherical related rates, slightly harder than circular related rates from yesterday. Our objective is to solve related rate problems dealing with the volume of spheres, and sometimes surface area if you're unlucky. But in any of these cases, they will always provide you the formula, so you don't have to memorize any of the formulas, which is really nice. So if you see R, you know this from yesterday, that means what? R is you got that right, it is the radius. So if I think about this sphere, it's the radius that comes out to the side. You can think of it the radius that comes up. It's the same radius, whatever you want it to be. And then the r prime is the rate of the radius. So how fast is that radius changing? And then S is going to be surface area. Surface area. And as you might guess, S prime is therefore the rate of the surface area. So rate of surface area. I cannot spell surface area. And finally, V, you can probably guess, is the volume. Oh my gosh, volume. And then V prime is the rate of the volume. Let's talk about units because units are important for this whole last 3 lessons. Let's just choose, I don't know, meters again. So if the radius is in meters, that means r prime is going to be meters per some time. I'm just going to randomly choose seconds. I can write a little bit neater, seconds. If I'm talking about surface area, let's assume, we're talking about areas now, so I'm talking about meters squared, and then if I'm talking about surface area, or S prime, it's going to be meters squared per second. Volume, you should know this. Volume is, it's going to be meters cubed, and V prime, you should know this as well. Go ahead and do it before me. It's going to be meters cubed per second. No, I said per second. All right, so units are important. You know what the variables mean. Let's see an example problem. So we have the volume of a balloon, and it has a radius r, is this thing, and it's just kind of a random equation at this point. Oh no, it's not. That is the radius or the volume of a sphere. So it's just the volume of a sphere. The radius is expanding at a rate of 14 inches per minute. At what rate is the volume changing when r is equal to 8 inches? All right, so everything is in inches and minutes. What is given from this problem? Obviously, the formula, I'm not going to rewrite that. That's already there. What is it asking for? At what rate is the volume changing? So I'm looking for volume rate. That is the box that I'm going to be doing. So V prime, that's the thing I'm trying to figure out. What information is given? The radius at a rate of 14. I can do that in a different color here. So the radius is at a rate of 14, and it's expanding. Expanding is a positive word, so that means that my r prime, because it's a rate of the radius, is equal to a positive 14. And again, I'll worry about units at the very end. What other information is given to us? We know that r is equal to 8, so that's just pretty straightforward. R is equal to 8. And we have this formula here, so I'm going to go ahead and rewrite this formula. I guess we do need it. V is equal to 4/3 pi r cubed. And we can take the derivative as well. I'm going to do that over here in red. If I take the derivative of the left is v prime. Derivative of v prime. So far, so good. And everything is taking the derivative with respect to t again, with respect to time, with respect to minutes in this case. If I take the derivative of the right-hand side, this 3 is going to be multiplied down in front, so it's going to be 3 times 4, and the 3 on the top and bottom are going to cancel out, so I'm just left with 4. So taking the derivative, I'm only left with 4. This is equal to 4, and I still have pi. I still have r. This goes down a power, down to the power of 2, and don't forget your dinner. I have to do times r prime. All right, now I have 2 formulas. Let's plug in what we know. Obviously, I'm looking for v prime. What is helpful in this equation? I know r, so I can plug in for that r. I know r prime. I guess I didn't actually need this equation. Sometimes you need to plug back and forth in between the non-derivative and the derivative. This is a case where you just need the derivative, because if I rewrite this as v prime is equal to 4 pi, we know what r is, R is 8, so I'm going to say this is going to be 8 squared. And sorry for all those that are colorblind. This is actually in green. This is in red. And then R prime is 14, so this is all going to be times 14. And I just have to plug and chug all these together. So 8 squared is 64, and I'm going to, you don't actually have a calculator on this part of the test usually, so you have to do all the mental math. This is going to be 64, 64, and then 14 times 4, I can do that in my head because it's going to be 16, carry the 1, so 56. So it's going to be 64 times 56. What is that going to be? That's going to be 6 times 4 is 24, carry the 2, 6 times 6 is 36, so 38. We're in the tens place now, so 50 times 4 is, or 5 times 4, sorry, is 20. So carry the 2, there's a 0, and then 5 times 6 is 30, plus 2 is 32, so I get 3,584 if I add those together. So that means that our final answer down here is that V prime is equal to 3,584 pi. And don't forget your units. Your units will always be some sort of point. So if I'm looking at volume, that means I'm in inches cubed, inches from here. So I'm going to have inches cubed, and it's V prime, so per time. And our time is not seconds, it's minutes in this case. So inches cubed per minute. And there is our final answer. Box it. Cool, so there's example 1. I think it would be helpful to do the first problem on the homework as well. So let me save that. It's now uploading to the website, and let's come down here to worksheet 4-8. Let's do the first problem together, yeah? So we have a spherical balloon inflating at a rate of 27 pi inches cubed per second. How fast is the radius of the balloon increasing when the radius is 3 inches? So very, very similar to the last problem. We know that if it's inflating at a rate of this, inches cubed, we must be talking about volume. That unit means volume. And volume is talking about a rate here, so we're really talking about V prime. So V prime we know to be, and it's inflating, so that's a positive word. V prime is 27 pi. What else do we have? How fast is the radius increasing? So it's talking about R prime here. So R prime, it's the thing we're trying to find. And it says when the radius is 3 inches, that means that R is equal to 3. All right, so I have a V prime. Let's go ahead and take the derivative. Derivative on the left is V prime. Derivative on the right, again, 3 is going to multiply down, and it's going to be 4 pi R. This is going to go down to the second power, and don't forget your R prime. From here, we need to basically plug in what we've got. So V prime is 27 pi. On the right-hand side, we still have this 4 pi R squared. We know what R is. R is 3, so it's going to be 3, and then I need to square that, and there's my R prime that I'm looking for. So looks like I have a good equation because I'm trying to solve for this variable. I'm going to divide both sides by pi. Sound effects, they're gone. I divide both sides by pi. 3 squared is going to be 9. If I divide both sides by 9, this is gone, and 27 divided by 9 is 3. And then finally divide by 4, and I get 3/4 on the left-hand side, and this is equal to R prime. And don't forget your units, so let me move my equal to out of the way so I can have some units in here. If I'm talking about the radius, I'm talking about a length, not area, not volume, just length. So my length is inches, so I'm going to say this is going to be in inches, and then it's R prime, so per time per second. All right, you guys can do number 2, number 3. Let's do number 4 together. I'm just like feeling like recording a video, so here we go. A spherical balloon is expanding at a rate of that thing. How fast is the surface area of the balloon expanding when the radius of the balloon is 4 inches? All right, so it's expanding at a rate of, okay, this is again in volume. So I'm going to say that our V prime is expanding. That's a positive word. So V prime is equal to 60 pi. Next we have how fast is the surface area of the balloon expanding. So again, this is S for surface area. It's saying S for surface area. And it's how fast is that expanding? Again, a positive word. It doesn't really matter, I guess, because it's asking for that. We don't need it to know. So it's looking for S prime. That's the thing we're trying to solve for. When the radius of the balloon is 4, so that means R is equal to 4. And that's all the information it gives us aside from these two formulas. So obviously I have a v prime and an s prime, which means I need to find a v prime and an s prime. Let's go ahead and take the derivative right now. So if I have v prime, that's going to be equal to, we've done this before, it's 4 pi r squared r prime. What about s? Let's do this in green. So s prime, that's the derivative of the left. Derivative of the right, 2 multiplies down, that's going to be 8. Pi r goes down to the power of 1. Don't forget your r prime, which is your dinner. All right, now we have s prime and v prime. What makes sense to start plugging things into? Well, we have an r. So if I plug in an r, I'm still missing an r prime. Oh, but I have a v prime. So we can find r prime from this equation. And when I find r prime, I can plug in that r prime. I have the r, and I have everything for s prime. Okay, so the general strategy here is let's plug into this equation first. And it's going to be one or the other, right? You have a 50-50 shot. So this r right here is 4. And then rewrite everything else. It's 4 squared, we still have an r prime, we still have a pi, we still have a 4, we still have an equal to. Oh, this v prime over here. V prime we know to be 60 pi, so this is going to be 60 pi. All right, so from here, we can do some math. Let's get yellow going here. 4 squared is 16. Does 16 go into 60? I don't think it does. We're going to have some weird fraction-y things happening. Oh, let's get rid of the pi's. Divide both sides by pi, yay. Now we just have numbers. I'm going to divide both sides by 4 to begin with. So 60 divided by 4 is 15. I know that because 60 divided by 2 is the same thing as divided by 4. 60 divided by 2 is 50, or 60 divided by 2 is 30. Divided by 2 again is 15. So I have 15 is now equal to 16 r prime. Again, 4 squared turns into 16. And then from there, I can say, okay, I know what r prime is. R prime is 15 over 16. All right, so I have r prime. Again, I'm going to plug that in here. We know what r is. Therefore, we can figure out what s prime is, which is what we're trying to find. So from there, I can say, yes, this r prime is indeed 15 over 16. We know that that r is this r, which is 4. So this is going to be 4 times 15 over 16. We still have a pi. We still have an 8. And that all together, once we simplify, will be s prime, the surface area's rate of change. So what do we have here? I could do the simplification of 4 and 16, but I think even faster would be 8 and 16. 8 and 16 turns into a 2, and then that 4 and 2, that 2 goes away, and I have a 2 on the top. Yeah, it's just going to be 30 pi. 2 times 15 is 30, and we get 30 pi. 30 pi is s prime. Don't forget your units. So our units here, if we're talking about surface area, then I have some sort of area, which means I have something squared. I'm going to have inches squared. So inches squared per time, because the derivative here is prime and it's per second. So per second, and we got an answer. All right, I want to do one more. I'm just feeling like recording. Let's do, I don't know which one is hard because I haven't done this in a long time. Let's do number 7. Maybe that one's the hardest. Is this the last one the hardest? Volume of expanding sphere again. Who would have thought we have spheres on here? Increasing rate at 12 units, 12 cubic feet per second. So this is a positive word, increasing. We know it's a rate of a volume, so it's going to be v prime that's talking about here. So this is going to say, yes, v prime is indeed equal to 12. When the volume of the sphere is 36 pi, so volume, not a rate, just volume is 36 pi, so v is equal to 36 pi. How fast? So we're looking for some prime thing in square feet per second. Oh, it even gave us the units. Easy peasy. Is the surface area. So we're looking for s prime. So s prime, we need u. All right. So, well, I have a v prime and an s prime, so that means I'm going to have to take the derivative here and take the derivative here. Let's go ahead and just set that on up. If I take v prime, we've not done this problem before. No, we have. It's 4/3 is the same thing. 3 multiplies down, 3 and 3 cancels off. And I have 4 pi r squared r prime, easy peasy. And then s prime, we've done it before. S prime is equal to 8 pi r prime. All right, so what do we got here? Well, I can plug in a v prime, but I'm missing an r and an r prime. I have 2 unknown variables, so that's not going to work. I can't plug into this equation either because r and r prime I don't know. I didn't know them over here. I definitely don't know them over here. So I can't plug into either of these 2 equations yet. But I can't plug into one of these two equations, right? Because I have a v and I haven't used that information. And that's kind of a general rule of thumb on the AP calculus test is if they give you information, you are going to be using it. It's very dissimilar to the SAT. The SAT likes to trick you and give you too much information. If they give you the fact that the volume is 36 pi, you better be using that 36 pi. So let's plug that into the v. I can't plug into v prime because a v. So v is 36 pi. I'm going to move over here. 36 pi is equal to, and then I'm just going to rewrite everything over here on the right hand side. So it's going to be 4 pi r cubed divided by 3. Okay, well I have one unknown variable and everything else I know is just numbers and constants and stuff. So let's solve for r to the power of 3, or just solve for r. Let's multiply both sides. Oh, hold on. Before we multiply by 3, that seems hard. Let's divide by 4 first. If I divide by 4, that's divided by 4. 36 divided by 4 is 9. So I now have 9 pi. Oh, and then I can multiply by 3 right now. So I have 9 after I divide by 4. 9 times 3, because I'm undoing the division. 9 times 3 is 27, so I now have 27 pi is equal to pi r to the power of 3. I should have done this from the very beginning. Get rid of your pi's. Divide both sides by pi, and oh, r cubed is equal to 27. Take the cube root of 27, and you have r. R is equal to 3. All right, well, that's a very big missing piece of the puzzle. Now I know this r, and I know this r. Oh, I also know this v prime, which means I have one unknown variable, and I can solve for that r prime. And once I know that r prime, I can plug it in here and find s prime, which is what we're looking for. Cool, we have all the pieces of the puzzle. So let's go ahead and use our v prime equation. Coming back over here, we know that v prime, I'll do a substitution over here, v prime is equal to 12, so this v prime is equal to 12. And that is going to be equal to, we still have a 4 pi, our r, we know this r is 3. So I come back over here and I say this is going to be 3 quantity squared, and I still have this r prime that I will be able to solve for now. So I'm going to divide both sides by 4, then I get 3 over here, and then I am going to divide by 9, and I get 1/3. So I have 1/3 is equal to pi r prime, and I can divide by pi again, so I get 1/3 pi is equal to r prime. I hopefully haven't made any mistake. I haven't actually been checking my work, but hopefully, if you guys catch the error, I mean, it's just extra credit, right? So we have r prime now. If I have r prime, let's plug that into r prime. We have r, we can find s prime. Here we go, s prime. We're about to solve you. That's 8 pi r, we know from down here is 3, so I'm going to write a 3 here in the corresponding color. And we know r prime down here in blue is 1/3 pi, so 1/3 pi. Oh, I see a lot of things canceling out on here. This is nice. So I see a pi on the top, pi on the bottom, gone. 3 on the top, 3 on the bottom, gone, and it's just 8. 8 is the loneliest number here, 8 times 1. So s prime is equal to 8. Write this in green here. S prime is equal to 8. But we're not done. We forgot the units. It gave us the units. There it is. How fast in square feet per second? So square feet per second means feet squared per second. Bada bing, bada boom, we got the answer. And that's all the recording I'm doing. You guys should be able to solve the rest of the problems on your own. Good luck. I'll see you guys on Monday. I hope you had a nice Halloween, etc., etc. Bye.